I'm Torsten Hager. I'm your speaker for today. And yeah, before we start with our presentation, I would like to give you some basic information about the tool we are using and the way it will work today. So first, if you have any issues with your Click Meeting tool, please check your browser, check if it works properly and if it has the last update. If not, try another browser. If this will also not work, you have the possibility also to switch to the mobile app on one of your mobile devices, Android or Apple, both is possible. And the second most important information for you is it's a listening only mode for you. So I will be the only one who is able to speak during the presentation phase. But you have the possibility at the right side of your screen to to send me your questions in a written way, to write them down. And after the presentation, we will have a look on the questions and I'm going to answer your questions as good as possible for me. Yeah, our today's webinar is about energy storages and their key role in a future energy system. And as you will see on the following slides, it's not only about storages itself, it's about, of course, the storage, but also the other systems next to it, like energy management systems and so on. It's about technology, but it's also about what are the drivers, the use cases for the customers to buy these products, to use these products. And it's about what we are already able to do within Hager, with our product portfolio. To start with, I would directly show you this picture where you can see on the left-hand side the very famous term Energiewende. It's a German term meaning energy transition, but I think it's globally known because it stands for the change of the complete energy system. And in my presentation today, the examples I would like to give are examples from Germany, because in the German energy market, we have already today about 250 to 300,000 energy storage systems installed and in operation. And it gives a good idea and a good overview what's possible with energy storages, why you need them, and of course, what they are able to provide to the energy system and to the end users. To start with the usage of energy storages, we have to differentiate between residential applications and commercial industrial applications. So you can find energy storages in both applications, but with different use cases behind. There is a real difference, and also the technology, of course, is differently between the two systems or the two fields of application. But yeah, you will see on the next or on the following slides why it is so important to differentiate between the two kinds of applications. Let's directly start with the usage of energy storages in residential buildings. We can see here on this slide a typical profile on the right-hand side. You see the blue curve here in the background, which shows a typical load profile of a residential building, of a single family home, in fact. And in yellow, you see the PV production. And typically for this is that in the early morning hours, as well as in the night, you have no PV production, but you have the peaks in consumption. Whereas in noon times or during the day, it's exactly opposite. You have a very high PV production, whereas you have a very or comparable low load within your building. And now the idea of the energy storage is quite simple. It's to take the energy you produce during the day and shift it with the storage system into the night hours and the morning hours of the following day. And depending on the size of the storage system, also to shift it to perhaps in 2 days when you have a day with a low PV production because the weather is not so fine. so that you have some reserves in your battery as well to increase your autarky or your self-consumption of your PV within your building. That's a typical approach in residential buildings for energy storages. And of course, you could ask yourself now, why should anybody invest in such a technology? Because it's yeah, it's quite large investment, I would say, for a residential builder or for a house owner. And yeah, the reasons are not often that clear why the people are doing this, but you will see on this slide now, the main drivers for it. And the very first one, which you can find in all the surveys we made and which are available in public, that the ecological reasons and the contribution to the energy transition is the main driver for the people to invest in this technology and to invest the money to install PV and battery storage systems in their house. Of course, there are others as well, which are more financially driven. You have the second one, which is about cost savings and independency from energy costs. This means it's a little bit different. It's not a return on investment calculation you do behind this. It's more to say, without PV, I would pay, I don't know, 1,000 euros per year to my energy provider. And if I install this, I will save 600, 700 euros. And that's the main driver for them to say, okay, I don't spend the money, I don't pay to the utility or to my energy provider. I'm going to invest it in my own building. Closely linked to this, there's the wish to be more autark, to have a higher autarky from the grid operators and from the energy suppliers, to be independent from the outside world. And another driver, which is again financially driven, is really the investment perspective, to say, okay, if I put my money on my bank account, I don't get any interest for it. So instead of doing this, I invested in my building, and with a return on invest of about 10 years for PV and storage. It really depends on the individual situation, how long it will take, but it's a rough estimation to have 10 years. It could be 8, 9 years, but it could also be 11 or 12 years. You invest your money in your building, and you get this long-term feedback. But afterwards, you will really earn money with it. And from the past, we know from PV that there's a funding period of 20 years. We will come to this a little bit later. But if you imagine you have a payback time of 10 years, you would have another 10 years to earn money with your system. And that's the idea behind this investment driver for the customers. But these are the drivers for today. If you look on the future, so in the next, let's say, about 5 years, we see additional use cases and drivers appearing in the market and driving the people to invest in such technology. The first one I would like to mention are local marketplaces for energy. The idea behind is that you are able to trade your energy, to sell your energy from your PV to your neighbor, for example, or to someone who is living in another city or wherever. And vice versa, also to buy your energy from the supplier you would like to choose. It could be your neighbor with his PV installation. It could be the wind power generator in your city or in the city next to yours, whatever. So you are really participating in the energy markets. Another driver which pops up is additional grid services to the grid operator. With the installation of renewable energies, you have a lot of new issues coming up in the network. And to solve these issues, energy storages could contribute a lot. Energy storages in general, but also other flexibilities, could really help to stabilize the grids and to make it possible to have more and more renewables in it. And therefore, these systems have to be connected to the internet at the end of the day, and to the grid operator system, so that together with the grid operators, the owners of the storage systems could contribute to the stability of the grid, and therefore they get paid. And a third use case is the so-called overload protection use cases, and therefore you have two dimensions you have to consider. The first one is it's an internal use case in the building where you try to avoid, with the usage of your storage, the dripping of your main fuse. So to avoid a blackout in your building, which could occur, for example, if you connect too many loads like electric vehicles or heat pumps or air conditioning, things like this. If you have too much load, it could happen. So with the storage and energy management, you try to avoid this. And the second dimension of this overload protection use case is grid related. So as a grid operator, you are heavily interested that in your street, for example, where you have a dedicated cable to supply all the households, that this cable is not overloaded and that the fuse in the grid is not tripping. And therefore you are really willing to give some benefits for the users or the providers of energy storage capacities and or flexibilities, how it is very often called as well, to avoid the stripping of the fuse in the grid. I spoke a few times about it, but not so much detail because the title of our webinar today is energy storages. But I mentioned at the beginning, it's energy storages is only a part of the environment. And here on the left-hand side of the slide, you can see the building with an energy storage, of course, but also with an electric vehicle, with a photovoltaic installation, and also with the heating and cooling system. And that's the key element I would like to dig in a bit deeper here on this slide is the energy management system, which is the orchestration of all these devices in the house. So a storage alone or electric vehicle alone, they could not really work. I mean, the electric vehicle would be like a normal load, or the PV would be just a generator, which is very volatile. The heating and cooling system would run when it would like to run, but there will be no energy management behind, and it would be completely unorganized. And to organize all this and to optimize it, to bring it to the best efficiency and the best usage, therefore you need an energy management system. And for an energy storage, it's absolutely mandatory because someone has to tell the storage when to charge or to discharge the battery. And that's the job of the energy management in-house, but it also makes the link to the grid, what we had before for the grid services, but also to the energy markets I've talked about as well. If we look on the grid's perspective, there is one basic thing which I think most of you are aware about. In the electrical network, unfortunately, the production has to be always the same as the consumption at each point in time. So you have no real storage capacities in this network. In the past, with the traditional generators, this was not a real issue. But if you now go in a system with a lot of renewables, which are fluctuating and volatile, you have always to balance this system. And to balance this is very, very difficult if you have no storage elements. And that's one of the key arguments to say energy storages are really the key of such a future energy system, because you can decouple production or generation of electricity from consumption. And that's the only way you can do it. Of course, you can use some flexibilities. You can control some loads to lower them or increase them depending on the production side, but you will never get this full flexibility as you can have it with an energy storage. And on top of this, it brings some additional benefits with it. The first one you can imagine, if you have a very local production of your energy and you can store it locally and use it afterwards locally, you can avoid the transportation of the energy within the network. And by avoiding the transport, you will avoid losses as well. A second factor is, if you have this very local system and this, let's call it local cells, these cells could work more or less independently from other cells. And this makes your total network much more robust against the blackouts. So even if you have in one region of the country or the continent, wherever of your network, an issue, the probability that it will spread over the full network is much lower with such a kind of decentralized approach. And last but not least, also very important, is that you can increase the capacity of your network for renewable energies, for fluctuating renewable energies. As I described before, you have always to make the balance between both. And if you have no storage capacities, you are not able to increase the production side with renewables higher than a certain amount, because otherwise you would have to stop production. Here you really, with storages, you have much more flexibility to use this and store this energy within your network. Another situation which we are facing very often today is if you have a street with several single-family homes, as it's shown here, but you have the same situation if you have a multi-family home with different apartments in it. And for each apartment or for each single-family home, you have one electric vehicle on a parking with a residential charging station. And what you see here in this diagram on the left is you have a substation. Here in this drawing, it's a 600 kVA substation. And the grid operators typically calculated for each house a load of 2 kVA, which was perfectly fine in the past. But nowadays, you see that this doesn't really work anymore. And by the way, you have behind one substation, in this example, 300 houses, so really 300 times 2 kVA, so you have the 600 kVA. But what you see here is you have an electric vehicle with only an 11 kVA charger, and you see the difference between the 2 kVA which are provided from the grid and the 11 kVA used by the car. It's a factor of 5.5. So there are 9 kVA which are missing. And in such a situation, of course, if all the cars, or even you don't need all, you only need 60 cars out of 300 would charge at the same time, you would completely overload your substation if it would be not controlled. And to avoid this, of course, you have the opportunity, and you see it on the second line of the picture. If you install first in the houses, you see the cloud, which stands for the energy management. If you have an energy management which is able to lower and increase the load of the electric vehicle, that's one dimension you can control. To control the system in total, what I called before overload protection of the grid. But for example, the second house you can see is only able to reduce the power from 11 kVA to maybe 2 kVA or 1 kVA, which would mean that it needs much longer to charge the car. Or as shown in the first house, if you have a PV production and the battery storage, you can directly, in this example, it's an 11 kVA storage and PV, you can directly charge the car from the battery or directly from PV. Or at least maybe you don't have to provide a full power to the car, but maybe only a small part of it, so that it doesn't take too long to charge the car compared to the scenario where you really have to slow it down to 2 kVA or less. So these are real practical use cases we are seeing in our daily life, and it's well known under it's an energy management topic, or sometimes it's also called local load management, which is behind this. And as I said before, here it's shown in a street, but you have it the same in an apartment building with a lot of car parkings in the cellar. So much for a moment for residential buildings. Let's have a quick look on the commercial buildings and the main motivations for the owners of these buildings to install a PV and storage systems. And the main driver for this today, what we see in Europe, is the peak load avoidance. So the idea behind, for those who are not really aware about this, is that the energy price for residential buildings is calculated or has two elements. The first element, and that's the important one, it's the power price. So you have to pay a certain amount of euros per kilowatt you are consuming from the grid for 15 minutes all over the year. This means if you have a 15 minutes period one time in your year, this maximum value will be charged for the full year in euro per kilowatt hour. And the second element is, of course, the euro per in euro per kilowatt, the first one. The second element is the energy price in euro per kilowatt hour multiplied by your consumed energy over the year. And yeah, the first element is power price. It's a very, very interesting part of your energy bill if you have an industrial or commercial building. So it's really, there's a big interest of this of the users of these buildings to reduce this power price. And you can do it, as we have seen also on the slide before, by installing an energy storage system. And in times when you are running to your peak load, you are discharging your battery to keep the peak as small as possible and to save money with this. Of course, there are also the use case of cost savings and independency from the energy cost by producing a certain amount of energy by yourself and to use it also by yourself. And last but not least, there's also this investment use case to say, okay, if I have some money left, it could be interesting to invest my building. Sometimes I get some subventions for doing this to make industry greener and so on. So these are the three main drivers for commercial buildings, and they are different than the residential ones, if you can remember, where the contribution to the energy transition was one of the key drivers. Let's now go a little bit more deeper into this commercial aspects, but not too deep, because these commercial aspects are very, very much related to your local situation and the local regulation. But in general, you can say, okay, you have on the left-hand side what's going out. On the bottom, you see the first thing which is going out is the investment. You have to pay for your PV and your storage hardware, for the installation and so on. On top of this, you have the operational expenses for maintenance of the system. The maintenance in residential, it's very low. It's more or less limited to sometimes cleaning up the PV panels or to make a check if all the PV panels are fine. In commercial, it's a little bit different. There, it's the regular inspection of the electrical installation should absolutely be done, and this is clearly recommended. Also, the currents and the power values are much higher than in residential, so that the risk of fire and things like this is is higher than in residential. But it's typically it's normal for all electrical installation that you should take more care about it for commercial buildings. Of course, you have to pay, and it's very typical, for example, for Germany again. If you consume your own produced energy by yourself, you have to pay value-added taxes on this energy you consume by yourself, depending on the scheme you have chosen for making your investment. And last but not least, if you cannot be 100% autark from your grid operator or from your energy provider, you have to buy some residual electricity or energy, and therefore, of course, you have to pay. And on your income side, on the other hand side, of course, you can, starting also from the bottom going up, you can get, depending on where you are, you can get some fundings for your installation. You can get some tax reductions also on your normal income taxes. Of course, the main two drivers for making this investment are the PV energy, or for the getting a return on invest on your installation is the PV energy you sell, and the main driver is the reduced grid energy. That's what I explained a few minutes before, the reduction of your energy bill by using your own energy from your PV panel. And typically we are talking here about periods of 20 years. And the PV production in this environment is about 10 cents per kilowatt hour, to give you an idea about the costs of a kilowatt hour you have to consider for production. That's the value for Germany, and you have to compare it to your grid energy price, which is about 30 cents per kilowatt hours. So it's 3 times more expensive to buy the energy than to produce it by yourself. We have the same picture for commercial buildings. Here there's another factor in it. You can see here the investment in OPEX is the same. I talked about it, but here you have the grid peak power, which is of course a very high share of your energy bill and the grid energy itself. And on the income side, you have the same. You have the funding for the installation, but then you have to reduce peak power. I explained this. You also get some money if you are able to sell energy to the grid, PV energy, and of course you will reduce your energy bill. Here it's a little bit different because the price is not 30 cents per kilowatt, but it's strongly depending on the size of your consumption. It could be about 10 to 15 cents, really depending on your business you're running. But important here is that you can see that the production cost per kilowatt hour, even in Germany, is 6 cents per kilowatt hour. If you go more to the south or to more sunny regions, this value could even go down to less than 4 cents per kilowatt hour. And then if you are less than 4 cents per kilowatt hour, you are in real competition to the traditional power plants, which are more or less on the same level, depending on the model behind, on the taxes they have to pay, on assurances they have to pay, etc. Okay, that's it about the economical perspectives of this topic. Now let's look a little bit more on the technology itself. I mean, everything starts with the battery, and the battery, it's the first point to be discussed. You have different types of batteries, different geometries. You have the cylindrical, prismatic, and pouch. They have all their advantages, but also their disadvantages. And you cannot really say the one is better than the other. It really depends on your application. And for the stationary application, honestly spoken, it doesn't matter which type of battery you are using. Here, it's really about to get a good and safe battery. That's something we will see on the next slides, what's important to look at. And on the second perspective, it's really to say, okay, where can I get a good price for it? And here it strongly depends on the manufacturers of the battery cells. We don't manufacture the cells by ourselves. We buy them from the large manufacturers of these components. And therefore, we really look what's available, what has the best performance with highest security and safety, and with the best prices. And maybe some of you have heard about different lithium technologies or chemistries, like lithium iron sulfate, like NMC cells, and so on and so on. So the different chemistries, all of them are in the group of lithium-ion batteries, but they have completely different specifications. But nevertheless, you can say in average today's lithium-ion batteries, they can reach an energy density of around 200, 220 watt hours per kilogram. That's the battery you see on the left-hand side. That's state-of-the-art technology. If we look a little bit in research and into the future, we see a lot of effort is done for the topic of lithium sulfur batteries. There are also already some products, I don't want to call them, but some prototypes available, which can reach about 350, maybe 400 watt hour per kilogram, but they are not stable enough in operation. So you have not enough cycles to charge and discharge them. But theoretically, they can reach energy density of 2,500 watt hours per kilogram. And you can compare this battery on the left, which is quite large, with this small battery here in blue. And that's the factor, that's the factor 10 or 11 from the 220 watt hours to the 2,500 watt hours, showing how much this technology can develop. And on top of this, there's the technology of lithium air battery, with which you can theoretically reach energy densities of 13,000 watt hours per kilogram. And you see there's a small blue dot only, so you cannot see it anymore. The idea behind this slide is really to show the potential we see in this technology, in the battery technology itself, because very often you hear, yeah, is this really future-proof, and will this last for longer times, or will not be the fuel cell the better choice, and so on and so on. But here you have to say the research, it started more or less 10 years ago again to work on these technologies. And yeah, the potential is so high. And what I was not talking about on this slide are solid state batteries. They are somewhere in between lithium ion and lithium sulfur batteries. So the energy density is maybe not as high as lithium air battery, but therefore the safety is incredibly high, and the robustness as well. So there's another trend which we are seeing in the market, which seems to be close to be ready to go in mass production, and it will be the next revolution in this domain, and we will see big steps. And with this effect, it will of course increase the energy you can store in your home or in your building, but also it will dramatically increase the range of your electric vehicle, and therefore it's very important to have these developments in the next years. I mentioned it a few times. It's the safety of the batteries, and therefore, yeah, you really have to consider this in your design of several components of your system, because it's not only the battery cell, but it starts with the battery cell. So you have really to choose the right cell design, the right material, and I already mentioned it, solid state battery is the most promising technology today to have really very highly safe battery cell available. But then in the next step, you make a packaging of the cells. So you put several cells together on one pack, which you have to cool and which you have to monitor. And that's the third layer for protection, is really the monitoring of the temperatures in these battery packs of each cell, and the currents in the system. And the currents, of course, you limit them by having at least fuses, melting fuses. But that's really for emergency case only. You have on top, you have a battery management system, BMS, which is really actively managing the battery and is reducing the current, for example, if the temperature increases too much in the battery, and really limits the battery, the capacity of the battery pack to the system outside, to keep it in this very secure window. You can see it on the left-hand side. Everything what's red in this diagram is forbidden for typical lithium-ion batteries. Only the blue area, the very small blue area, is the safe one, and that's the challenge for the battery management system, to keep the battery cells really in this area. And you see, therefore, you have to really closely monitor the cell voltage, means charging and discharging of the battery, as well as the temperature range in which you are operating it. Now we have talked about the battery cell. We created here the battery pack with all the protection stuff. And if we go one level higher, you see here the converter. So you need some power electronics on top of the battery pack to discharge and charge the battery, and to convert the DC current from the battery to AC current, which is used in the electrical network, either in 50 Hertz or 60 Hertz on the dedicated voltage level of your grid, of your local grid, and so on. And on top of this, as a third element, we had it a few slides before, you have the energy manager orchestrating all the interaction between the grid and or the house and the energy storage system itself. For the design of the system, you have in fact two types of energy storages or battery storage systems. You have the DC connected systems, where you have a DC link between the battery and the PV and the grid. So you have a DC intermediate circuit where all the three elements are coming together and where the energy is routed in one or the other direction. Or you have a little bit simpler architecture of an AC connected system, where the battery is directly connected with an AC-DC converter to the network, and your generator, like PV here, is connected also with a DC or AC-DC converter to the AC network. And if you want to charge your battery, you convert your DC current from your PV in AC and convert it back to DC to charge the battery. Both systems are present in the market. They have both the advantages and disadvantages. And usually, if you have a DC connected system, it's also able to charge the battery from an AC source as well. So you could have beside a PV, you could have a genset or fuel cell or whatever you would like to have. That's also possible to do this combination, of course. I spoke a lot about the energy management system or the energy manager. Within Hager, we like to call it also energy intelligence, because the idea behind this energy intelligence is really to analyze the current situation, to make predictions for the future, and last but not least, to control the several devices. And the devices could be what we had of PV. It could also be wind power plant or the genset for cogeneration. It also could control some loads like white goods or brown goods in your home. You can connect it to your home automation system to switch on or off some other loads. And last but not least, of course, we can control the energy storage, heating and cooling system, as well as the electric vehicle. So it's really about connecting these different players in the house and about the algorithms. That's the key, to have the good algorithms on your energy manager, the good energy management algorithms, to take the right decisions at the right point in time to have the best efficiency for your installation. And this means at the end of the day, you really need software skills to do this. And yeah, we are quite happy to have these skills to be really able to provide very, very good energy management systems together with our storage systems. And if I'm talking about providing these systems, let's really have a look on our real solutions. I've spoke now a lot about the theory, about the basics of it. Let's now become really practical. Let's have a look in our product portfolio. And you will see on this slide that we have a quite nice range of systems available. Starting on the left with smaller systems for residential buildings, going to the right for systems which are more for industrial and commercial application. And you see, I don't want to go in all these technical details, but you can see that we have comparable small systems. On the left-hand side, the S10 Mini system with a 4.6 kilowatt charging discharging power or discharging power from this system. They are all, or the three on the left-hand side, the S10 Mini, the S10e, and the S10e Pro, DC connected systems, whereas the Quattroporte and the H series are AC connected system. So on the left-hand side, if you have the 4.6 kilowatt, it's the power which could come from the PV into the building, plus the power from the battery. The battery itself could be charged and discharged with 1.5 kilowatt. And you see also the battery capacity is comparable small with 6.5 kilowatt hours. Whereas if you go to the S10e, or let's directly go to the S10e Pro, which is an improved version of the S10e with higher power, you have here on the AC side, you have 12 kilowatts, but from the battery, you can directly get 9 kilowatt. With this system, you can really run your building independent, either completely from the grid, so you can completely run it off grid. It's a use case which is very often used in regions where grid connectivity is very expensive. For example, in some holiday regions or some holiday islands in Europe, where you have a weak grid infrastructure, or where you have long distances between your building and the next grid connection point. And instead of making these investments of about 150,000 euros, the owner of the building is preferring to install for about 30,000 euros a nice PV installation, plus such a kind of storage and energy management system, so an S10e Pro, and then it can run 100% independent from the grid. But this type of systems are also used in grid parallel as normal behind the meter systems. And you see, you can here have a maximum battery capacity of 39 kilowatt hours today. If we go more on the commercial and industrial side, you have a Quattroporte solution, which is a system which is is flexible. You can start with only one of the bricks, but then you can scale it up. In theory, or what we are offering today is a maximum capacity of up to 78 kilowatt hours with a power of 13.5 kilowatt. So it's a really scalable solution. And even this solution could, in theory, if required in a dedicated project business, we have also realized some larger installations with it, but then it's out of the normal catalog solution. And last but not least, the H series is a really high power system for really commercial application for the peak shaving with up to 176 kilowatt and up to 220 kilowatt hours battery capacity. So really high performant, high power, high energy storage solution for this domain. And to show you that it's not only theory, what I'm showing you, that we really have the systems, I would like to share some pictures with you. On the left-hand side, an S10e system installed in a normal cellar. On the right-hand side, two S10e Pro systems, black ones, also installed in the cellar. So it should give you an idea about the size of the systems and how they really look like and where they are typically installed. So it's really a typical environment where it is installed, technical rooms of the building. So not in the living rooms, but really here in the technical rooms. Here on the left-hand side, and that's what I've mentioned before, here are three quadriporter systems installed together, so to get up to 156 kilowatt hours. So you see it's more than the official value we have shown in the catalog before. It was based on a project business, and together with this, we also installed a PV installation using our own PV inverters. We have also in the catalog, I didn't mention them. So with this, we made a PV installation of 174 kilowatt peak by using 10 of our PV inverters. And all these things are connected together with our energy management system to orchestrate charging and discharging of the solution. If you really want to see more of this, I can fully recommend you the email address, the YouTube channel of our brand E3DC. On this channel, you can see a lot of videos about the energy storage applications, user stories to show showing you how the systems are installed and operated and what the customers are thinking about it. Unfortunately, as our main market today is Germany, most of the videos are in German and the customers are usually speaking German. But nevertheless, either you are able to speak German, then it's very interesting for you to watch it. Or even if you don't really understand what the people are saying, you get a good idea by seeing the pictures, what it is about and what we are doing here. So thank you from my side for this. That was my presentation so far. And now let's come to your questions, I would recommend. The first question I have here on my screen is, what about space requirements and safety specifications and compatibility in residential buildings? Do we need to consider this during civil construction phase? Yeah, that's a very good question. It's a very good question. I can give you the example of Europe. If you go to different countries, you have completely different requirements you have to respect. So it really depends on the local philosophy and the local habits. And to give you just one example from Germany and France. In Germany, if you install typically a PV panel on your rooftop, you take the cables, you have, of course, you have a double isolated cable. You are bringing this to your cellar without any real special measures. Of course, you have normal cable trunking or something like this, but nothing special. Whereas if you would like to do the same in France, in the past, it was really, really highly restricted and you really had to use fire protected cable trunkings and really heavy equipment to do the same installation. That's the reason why I can say, generally, yes, you have always to take care about safety in this topic. You have to take care about the right location for it. It should not be too hot and not too cold. So it should not be under under 0 degrees, or better not under 5 degrees Celsius, because otherwise you could get some problems in the chemistry. And the same is for the higher temperature. It should not be too warm for two reasons. First, you would have to limit your power, because the power electronics would reach their limit much earlier, as well as the battery lifetime would decrease if it's too hot, what we have seen before on this red diagram, if you can remember. I hope I was able to answer your questions with this. Yeah, what's the annual lifetime for batteries? Also a very, very good question. The lifetime of a battery is affected by two things. The first is the usage of the battery, and the second thing is the calendrical lifetime of a battery cell itself. What we can see here is we are operating in the stationary batteries, the batteries in a very, very low, under very, very low power values. So the idea is not to go to we are far away from their technical limits to really increase the lifetime of these batteries. So that the idea is really for us to have here a lifetime between 15 and 20 years for the battery cells itself, coming more and more to the 20 years with the newer technologies. And on the other hand side, to really take care with different measures to limit the load on the battery, and to not affecting their lifetime by reducing the currents as much as possible, by really taking care about the temperatures, and to keep them on a good state of charge. If, for example, if you have periods in the year where you say, okay, I don't need the full capacity of the battery, maybe not to charge them completely empty, but to keep them on a good level, to increase calendric lifetime. So all these measures are taken into account to really increase the battery lifetime. Is there a study to compare the financial returns between PV plant alone and PV plant only, PV plant with a storage system? I would say yes and no. It's very individual. So it really depends on the individual situation of the building itself, but also on the usage or the energy usage of the building. So that you cannot say the one is better than the other. It really depends on the individual situation. But what we have seen in real life is, and that was what I've shown at the very beginning, the use cases for the main motivation in residential application is not the return on invest, not the financial benefit. It's more the contribution to the energy transition, to be green, to have a good feel by using green energy. And for these people, they see that with the storage system, they can increase the PV consumption, and therefore they accept that a PV installation alone would have a better return on invest than a PV installation with storage. In both cases, you get a return on invest, but sometimes it's better with PV storage, sometimes it's better without, but it's not the main driver for decision. In commercial, it's a little bit different. In commercial, the use case is different, because there it's about this peak shaving, and this peak shaving is only possible with storage. So with purely PV, you cannot make peak shaving. So therefore, the study would not make sense. What are the possibilities of applying to be an international partner to offer these products along with other energy solutions like EV charging and other global? And would you give exclusive rights to sale in those markets? Here, it really depends, and therefore it would be best to contact directly our local partners to check with them about the business model. It really depends on which countries you're talking about, what our own footprint in these countries is, what partners we already have, and so on and so on. So therefore, I would really recommend to get in touch with our local team and to check with them the possibilities. Very, Yeah. Okay, now I got it. I'm not so sure if I really got the question behind what the inverter system is, PWM or MPPT technology. I think MPPT is the maximum power point tracking you mean, but I don't know what you mean with PWM at the moment. For me, it's pulse width modulation, but I don't see the connection between the two, because PWM is of course used for the internal control of the semiconductors. Yes, in some architectures we are doing this, but on the other side, the MPPT is of course used for controlling the PV plant. Here it would be helpful for me to get more information about the question, what it is really asked, and maybe it's better to write this question per email to get a technical answer, because maybe I have to ask some of our technical development team to give you an appropriate answer now. Okay, you would like to have a range of price per kilowatt hour for your energy storage solution. Therefore, it's really difficult for me to answer this question. Give me a second. I have to make a very quick calculation to do this. I just made a rough calculation. So at the moment, we are reaching a value of about 15 cents per kilowatt hour, but also strongly depending on the full infrastructure and all this in the local circumstances. And it's a value because I had to calculate this, because I can remember it was 5 years ago when I was asked this questions the last time, and there we were talking about 22, 23 cents per kilowatt hour. So you see the figure has dramatically improved. And yeah, I think we are still on track, and that's what we have seen on the battery side as well, with higher energy densities and new battery technologies. The prices are going down and down year by year, and then therefore, and with this, we are increasing exactly this value. Any other questions asking to you, Hager? So I still have the last question in front of me. Here's the next one. Yeah, the question is about power factor correction. You don't need any special PFC solution for this, because we have an active PFC, in fact, in the storage system in the inverter integrated. So the storage system itself is always compliant to the local grid regulation. It's a use case I was not talking about, but in theory, it would also be possible to use the storage system as active PFC. But that's something which is not very common today. Batteries are part of energy management system. Is there any load shedding program available for adapting energy management system? Here it really depends on the local on the specific countries and the local regulations and the local programs. So globally spoken, I cannot give you any answer for this. The energy management system itself, of course, can make load shedding if required, and also the storage system can contribute to this load shedding by, on the one hand side, by reducing his charging power, of course, but also in the negative side to discharge the battery, which is working the same direction as load shedding. But if there is a local program or something like this is available for this, it has to be checked really independently. Also, this is a very good question. Do you think the installation of such systems in buildings would be mandatory for civil compliance in future? I can tell you yes, and I can give you a clear yes, because we have some regions in Germany where it is already mandatory to have it. And of course, it will be different from country to country. But looking on Germany, I can say clear yes, and I'm expecting other countries to follow this. Okay, I think that was the last question.
Yes, thank you so much, Torsten, for the very interesting presentation, and everyone for attending. It was very interesting, really. So I hope you enjoyed it. Please feel free to take the 1-minute survey right after the webinar, just to let us know your feedback and help us to improve our webinar content. Please know that during August, we will have a short break and we will come back with a new program for September. So please keep following us on the LinkedIn page, Hager Middle East page, or on our website. Thank you so much. Thank you, Torsten, and have a nice afternoon or evening. Bye-bye.
Thank you, Heba, and bye-bye.
Thank you. Bye.